In this video, we're going to look at some review topics from basic algebra. You can pause the video as we go through it and see if you can work these out on your own, and then you can watch me solve them for you. We're going to look first at linear equations. So let me start at a little bit more basic one. You have something like x minus 8 is equal to 12. Solving an equation simply means to find the value of the variable. In this case, it's going to be x. That makes the equation true, makes the statement true. Now you can have two variables, one variable or more. In this case, we're looking at one variable. So we have x subtract 8 is equal to 12. That means some number subtracting 8 gives me 12. What is that number? Now you can figure these out in your head, or you can just do the opposite operation. The object is to isolate the variable. In this case, it's only one x. So we get rid of this right here by adding the opposite to that. Minus 8, add 8. So these cancel, minus 8 and 8 cancel. That leaves you with x. On the right side, 12 and 8 is 20. And that's the thing with equations. You can always check your answer. Put a 20 where the x is. 20 minus 8 gives me 12. That checks. If this had been a plus 8 here, then I would add negative 8 to both sides to isolate the variable. Now if it's multiplied, let's say we have 2x is equal to 12. It's saying, now again, if the number and the x or the variable are together, that means multiply. So it's saying 2 times what number gives me 12. So if you can figure that on your head, go ahead and put it in there, x equal 2. In this case, it's going to be 6. Or we do the inverse operation. Divide both sides by 2. Always want to isolate the variable. These divide out. This is now 1x. If I don't put a coefficient, it's understood to be 1. So I just leave it as x. And then 12 divided by 2 is 6. Go back and check it. 6 times 2 does give me 12. Now let's look at this first one then. We have 2x minus 8 is equal to 12. Now if you can combine terms or simplify one side or the other, you go ahead and do it. In this case, I can't do anything here. So I simply say, well, let's get rid of this minus 8 by adding 8 to both sides. Minus 8 and 8, those go to 0. On the left side, that leaves you with 2x. And then on the right side, 12 and 8 is 20. Now I have 2x is equal to 20. I want to make that 2 into a 1 to isolate the x. So I simply, well, 2 divided by 2 will cancel. We'll make it a 1. But if I do that to the left side, I have to do it to the right side. So now these divide out. That gives me 1x, or just x. And on the right side, 20 divided by 2 is 10. That's your answer. You can check it. 10 times 2 is 20 minus 8 gives me 12. Now the next one, I look at the left side. Again, it's a linear equation. X minus 3 is equal to 2 times 2x plus 1. On the left side, I can't do much with that. I always want to simplify each side. So x minus 3, nothing I can do. Now the right side has parentheses and then in front there's a 2. That's implied you're going to multiply here by 2. So 2 times 2x is 4x. 2 times 1, bring down your sign, is 2. I've got x minus 3 is equal to 4x plus 2. I can't add the 4x and the 2. They're different. They're not like terms. So what I do is I always want to isolate the variable. So I want the x's on one side. So what I can do here is this. I want the x's together. So let's bring this 4x over to this side. That makes it a minus 4x. And let's take this 3 minus 3 over to this side. The 2 stays there. And just remember, when you bring one term over from one side of the equals to the other, it changes the sign. And this should be an x here. So taking that over to the other side, that becomes a plus 3. And all we're doing is just adding the opposite. So basically I added a negative 4 to this 4x here, and that canceled. So and then I added it to the other side. I added 3 to this one here, and then added it to the other side. So now, remember this is a 1 here. X, the terms are alike. I can combine. What do I do if the terms are alike? Add the coefficients or subtract. In this case, 1 subtract 4 is negative 3. And that's an x. 2 and 3 is 5. So I got minus 3x is equal to 5. I want this to be a 1. So I simply, anything divided by itself is 1, as long as you don't divide by 0. So let's divide this side by negative 3. Whatever you do one side, you have to do the other side. We're just using properties of equality. So these now divide out. That just gives me an x. And the right side, I get 5 over negative 3. That's reduced. That's as far as we can go. Let's put the negative on top though. Negative 5/3. That's your answer. The next one again is still a linear equation, but it has fractions. I can simplify. I could isolate the 1/3 x by adding 3/4 to both sides and so on. But anytime you have a fractional equation, whether it's a linear equation or a quadratic or higher, table of fractions, it makes it easier to solve. So look at the denominators. We have a 3, a 4, and a 6. What's the lowest common denominator? Well, that's going to be a 12. 3 goes into 12. 4 goes into 12 evenly. 6 goes into 12 evenly. And then you just multiply every term of both sides. So 12 times 1/3. So just look at it this way. 3 into 12 is 4, and then 4 times 1 is 4x. And then on the next one, multiplying everything on both sides by 12. 12 times minus 3/4, let's go 4 into 12 is 3, and 3 times minus 3 is a minus 9. You can look at this as 12 over 1 if you want. And multiplying fractions, you multiply the numerators and the denominators and then reduce it. On the right side, you can go 6 times 1, 1 times 12, but that's still going to be 12 over 6, which will be 2. Okay? You can go 6 into 12, 2 times 1. Now the next one, this is over 1 if you want. Minus 3x over 1, so it's minus 3x times 12 is a minus 36 over 1, so it's minus 36x. So I want this term here on this side, or this one over here. Doesn't matter where the x is. You want to isolate the x. It could be on the left side, it could be on the right side. So you can think of it this way and say, okay, it's going to be 4x. I want this one on that side, so I'm going to just bring it over. Just change the sign. Anytime you go from one side of the equals to the other, you bring in the term. Just change the sign. And then on the right side, the 2 is going to stay there. I want the numbers on one side and the variables on the other side. Okay, so now the minus 9, I want it over, so just bring it over, so change the sign. So you can think of it this way. I added 9 to both sides to get the 9 over here. 9 here, canceled it. Minus 36x, I added a positive 36x to both sides. Canceled it over here, and then added it over here. There you have it here. 4x and 36x is 40x. And then 2 and 9 is 11. Almost there. I've got to get x by itself, so let's just divide both sides by 40. Notice it's always the inverse operation. I'm multiplying by 40 here, so I divide by 40 to get rid of it. So these divide out, gives me a 1x, or just plain x, is equal to 11 over 40. Now keep in mind that you can always check your answer by substituting the solution you got into the original equation. I do want to caution you that a lot of times, especially in this case, it would take you longer to check it than it would to solve it. So you're not required to check it. Just make sure you take your time so as you don't make any mistake. Because you make one little mistake with a sign or addition or subtraction, your answer is going to be wrong. Your teacher may give you partial credit, or he or she may not. So get 11 over 40 here. Now the next one, a couple of ways you can do it when you have one fraction on one side and one fraction on the other side. You could do the same procedure. Say, okay, what's the lowest common denominator? Can't simplify the left side anymore. The right side's already in simplest form. So 5 and 3 both go into 15. So that's your lowest common denominator. So I multiply by 15. So now I go this way. And I could put that 15 over 1. But if I do it this way, 5 into 15 is 3. And then 3 times 2x is 6x. And that's going to equal 2. Okay, now the right side, 3 goes into 15. I can go 2 times 15 is 30. Divided by 3. Or I can go 3 into 15, it's 5, times 2 is 10. Same thing, see, 3 times 15 is 30, divided by 3 is 10. Now once I get to this point, I want to get x by itself. So divide both sides by 6. This divides out, giving me x. And here just reduce it. 10 and 6 are both divisible by 2. Divide 2 into 10, I get 5. 2 into 6 gives me 3. So your answer is 5/3. Now this particular one, as I started to say earlier, when you have one fraction on the left side, one fraction on the right side, it's not going to work if you have several terms on one or the other side. But here you can just cross multiply. 2x times 3 is 6x. 5 times 2 is 10. And see, I get the same equation there. And of course the answer is going to come out the same too, 5/3. Now again, this is not going to work if you have, say, plus 1/3 over here, something like that. There you have to just multiply everything by 15, the lowest common denominator, and then follow the procedure I just went through. Okay, the next one, give the slope of this linear equation. This is a linear equation. Notice it has two variables. You can graph these and you're going to get lines. So you can have a line that looks like that. They go on forever at both sides. You can have a line that's horizontal. You have a line that's vertical. Or you can have a line that goes like this. The slope of a line is usually denoted by m. So a line that goes up this way has a positive slope. The line that comes down this way has a negative slope. A horizontal line has a slope of 0. And a vertical line has undefined slope, or we simply say no slope. So the thing you have to know here, you can get the slope of a line if you know it's vertical, no slope. If you know it's horizontal, slope is 0. If you know it slants this way up, you know the slope is positive. If it slants this way coming down, then the slope is negative. If you're given the equation, you can get the slope of the line, or if you're given 2 points of the line, you can get the slope also. But you have the equation of a line in this format. In other words, it's solved for y. This is called the slope-intercept form. Because if you have the equation solved for line, if you have the equation solved for y rather, the coefficient of the x gives you the slope, and the other number here is your y-intercept, which we denoted by, say, 0b. So for this one here, solve it for y. So again, same sort of thing as I do with equations. I want to isolate the y. So I bring the minus 8y over to the right, makes it a positive. The 7 goes over to the left, makes it a negative. Then I divide it through by 8. So this is to me, every term is divided by 8. This one's divided by 8 here. This one's divided by 8 here. This one's divided by 8. This is an x here. So it's in this format. Y is equal to, and this is your mx here, so just reduce that. 2 over 8 divided by 2 reduces to 1/4. So that's the slope of the line that has this equation right here. Give the slope y equal to, notice this one is solved for y, but it doesn't have an x. That simply means that the coefficient of the x is 0. So if I rewrite it in the slope-intercept form, this would be m. Y equal to mx plus 6. In this case, this is your b, or your y-intercept. So the slope for this one, denoted by m, would be 0. This would be a horizontal line. If I were to graph this, the slope-intercept, or the intercept, y-intercept would be 0, 6. So I go 6 units up here, and that would be a horizontal line. It's a horizontal line. Slope is 0. Okay, here's some problems involving monomials. So we've got two monomials multiplied together here. So all you got to remember here is to multiply the coefficients and then pair up all the like variables. So something like this. So these multiply together. Coefficients together, 2 times negative 3. And then we have an x to the third. Those go together. X to the third. X to the 6. Don't really have to put them in parentheses here, but just so you can see these go together, because it's all multiplication. And then we got y to the fourth times y. And then the first expression, parentheses, doesn't have a z. The second one does, so the z to the fifth goes by itself. And remember, if the variable doesn't have an exponent, it's understood to be 1. So now we just do this. 2 times the negative 3, just multiply those. Regular multiplication of signed numbers, that's negative 6. We've got x to the third, x to the 6th. Powers are the same base, x and x. You add the exponents, so that's x to the 9th. Y to the 4th, y to the 1st, bring down the base, that's y. 4 and 1, remember this is understood to be a 1, that's 5. And z, it's only one term of z to the 5th. So we're multiplying powers of the same base. You bring down the base, you add the exponents. Cancel this. The next one is similar problem, except this one has parentheses and then a power. So here you just have to remember that when you have a power to a power, you multiply the exponents. So let's do it this way first. Each of these terms inside the parentheses has to be taken to the third power. So this will be negative 2. Take that to the third. Okay, because it's this whole thing in the parentheses taken to the third power. And then I write that to y to the 7th. That's taken to the third power. Then I have a z taken to the third power. And then I have the next one, okay? This next parenthesis is taken to the fourth, so everything inside is taken to the fourth power. So this will be x to the third, taken to the fourth power. Y to the fourth, put it in parentheses, that's taken to the fourth power. And then z to the second, taken to the fourth power. And then we go ahead and perform these operations. So negative 2 to the third power means 3 factors of negative 2. So it's negative 2 times negative 2 times negative 2. That's going to be negative 8. And we bring down the next y. So here I have y to the 7th taken to the third power. Again, remember here that power to a power, multiply the exponent. So this will be 21. This is a 1 here, remember. So power to a power, multiply the exponents. That'll give me 1 times 3 is e to the third. The next one, these are multiplication. I'm going to drop the parentheses now. X to the third taken to the fourth. That's 4 times 3 then. X to the 12th. These are all times here. Y to the fourth taken to the fourth. Multiply exponents. 4 times 4 is 16. And then z squared to the fourth power to a power. 4 times 2 is 8. Now this one is like the last one. Now everything's set, so we negative 8. So let's bring the different variables. So we have an x. I'll put them in order here. X to the 12th, and that's all we have. Just one x to the 12th. No other term with an x. So this would be 12. Then let's bring down the y. Multiplying powers of the same base, we bring down the base, add the exponents. So y to the 21st, y to the 16th is y to the 37th. And bring down a z. Have a z to the third, z to the 8th, again, powers multiplied to the same base. We add the exponents, bring down the base, 3 and 8 is 11. So we get negative 8, x to the 12th, y to the 37th, and z to the 11th. So this is an exercise in multiplying monomials, and also an exercise obviously in using the rules or laws of exponents. Let's clear this. Now we have radicals. Just remember that if you have a square root of x, the x is the radicand, and this is your index. Now if it's a square root, the index is understood to be 2. That's understood to be a 2. Now if it's a cube root, you have to put it in there. Or a fourth root. But for a square root, it's understood to be a 2. So you can have, again, say the square root of 4. It's simply asking what number squared is 4. Well, it's 2. You have a cube root. Say we have cube root of 8. Cube root of 8 means what number cubed gives me 8. Well, it's going to be 2. 2 to the third power is 8. Now, when they ask you to simplify a radical, in this case it's the square root of 72. So in other words, if they ask you to simplify the square root of 7, that will be simplified if this radicand doesn't have any factors that are perfect squares. Say, well, 2 is the same thing as 36 times 2. So using properties of radicals, you can break this down into the square root of 36 times the square root of 2. Now, the square root of 2 is always simplified. It doesn't have any perfect square factors. And the square root of 36 is 6 because 6 times 6 is 36. So I just put a 6 here and the square root of 2. And that's your simplified form. Now, when you're adding or subtracting radicals, you can add them. You can have, say, the square root of 2 plus 3 square root of 2. If they're both square roots, the radicand's the same. You treat this like if it were a 1x plus 3x will give you 4x. Well, here it's 1 radical 2 plus 3 radical 2. No problem. This will be 4 radical 2. Just add the coefficients. But if this were, say, square root of 3, then you couldn't combine those. This would be your answer. So when we look at the next one here, we have 3 square root of 24 minus 2 square root of 150 plus the square root of 7. The way it is there, I can't combine them because they're all square roots, but the radicand is different in all of them. So what you do is you try to simplify this. So here's for 24, you can say, well, 24 is 4 times 6. 4 is a perfect square. So you try to simplify this. You try to find all the factors that are squares, perfect squares here that divide the 24. For the 150, 150 is the same thing. If you try to break it down, 25 times 6. The 7, can't do anything with that one. Let's go over to 7. So now we can do this. Break this down into the square root of 4 and the square root of 6. This one breaks down into the square root of 25 and the square root of 6. Now the square root of 4 is 2, and that comes out and multiplies this coefficient. Square root of 4 is 2 times 3 will give me 6. And that leaves me with a square root of 6. And the next one, the square root of 25 is 5, and I have a minus 2 out there, so that comes outside, has to multiply that minus 2 there. So that'll give me 5 times minus 2 is minus 10. And it goes to bring down the square root of 6. Plus radical 7, or plus the square root of 7. Can't do anything with that one. That's all in simplified form. Can't combine it though. So the ones I can combine are these right there. So this is just like if you had a 6x minus 10x. You can combine the coefficient 6 minus 10 using your rules for sine numbers is a minus 4. Bring down the square root of 6. And then bring down the square root of 7. That's as far as I can go with this one. This is your answer. Just if it came out, it might turn out to be, if you're dealing with variables, this might be minus 4x plus y. They're different. Same thing here, square root of 6 and square root of 7 are not similar. Now if you're dealing with radicals again, the answer is not considered simplified if there's a radical in the denominator. So here I have 10 over the square root of 5. I got to get rid of the square root of 5 here. Best way to do it here is to multiply by the square root of 5. So what I'm doing here is making this 5 right there into the radicand into a perfect square. That's legal, but I have to multiply the numerator by that also. So this then gives me, see, all I'm doing is multiplying by 1. Radical 5 over radical 5 is 1. So all I'm doing is multiplying that expression by 1. Doesn't change it. Just writes it in a different form. So 10, that gives me 10 square root of 5. And then this, if I multiply this out, that's the square root of 5 times the square root of 5 is the square root of 25. And the square root of 25 is 5. No more radical. But here, these are just regular. This 10 is not a radical, 5 is not a radical. I can divide those out. Regular numbers. 10 divided by 5 is 2. Gives me 2 square root of 5. And that's your simplified answer for that one. Now the last one I have, factor x squared minus 7. So we can factor binomials that are difference of squares. So x squared minus y squared, if you have a difference of squares, gives you two factors, one being the difference of the square roots and the other being the sum of the square roots. So x squared minus y squared factors into x minus y, x plus y. So let's look at this one, x squared minus 7. Well, if that were x squared minus 9, you have difference of squares. So using this formula, this would give me x minus 3, x minus 3 and x plus 3. So that's what we have if we have a difference of squares. Now this is not a difference of squares here, but sometimes you can force the factor in here by doing this. I can write this way, because if I put the square root of 7 and then square it, square root of 7 times square root of 7 is the square root of 49. That does give me 7. So now if I write it this way, I can force the factoring and say, okay, I have difference of squares now. You see the square right there. This would be x. One factor would be x minus the square root of 7. And the other factor would be x plus square root of 7. And you can see, you can multiply this out. X times x is x squared. X times minus radical 7 is minus radical 7. X times radical 7 is x times radical 7. Those cancel out. And the product of these two right there is minus the square root of 49, which is 7. So this just gives you a little review of some topics in basic algebra. If you have other topics that you want to see videos on, you want to review for your first algebra course or whatever, just leave a suggestion in the description of the video, and we'll see you next time. Thanks for watching.